Welcome, and we are going to continue using trigonometric functions with right triangles. And so these are just going to be some more examples for you to work through. First example that we're going to look at, it says that we have cosine of an acute angle is A, that's the angle, is 4/5. So construct a right triangle with this acute angle, label its sides, and then evaluate cotangent of A. So let's construct the right triangle. Okay, so I am going to make just a sketch of my triangle. Make sure it's a right triangle because, again, trigonometric functions only work in right triangles. Okay, and I'm going to label this as angle A, and then this will be B, and that'll be C. Okay, and then so it says for this angle, right, it says cosine of angle A is 4/5. Okay, and we know that cosine is the adjacent, the ratio of the adjacent side of the triangle to the hypotenuse. Okay, so I can actually go ahead and say, okay, since this is all in ratio, I could say that this side, again, with respect to this angle, this would be the adjacent side, so that would be 4, and then the hypotenuse would be 5. Okay, so then that leaves me with trying to find this side, perhaps. So it says label the lengths of its sides. Okay, so I do need this. Find that side using the Pythagorean theorem. And so let's give this an unknown name, y, and then to find that side, use the Pythagorean theorem. Let's see, we'd have 4 squared plus y squared is equal to 5 squared. Okay, go ahead and work that through. So 16 plus y squared is equal to 25. And then subtract y squared is equal to 9. And then from here, we would get that y is equal to plus or minus 3. But again, we ignore the minus because we're talking about a triangle side, and then we can't have a negative side length. Okay, so this is 3. All right, and then finally, this is asking us to evaluate, so I have all the sides, I have the right triangle drawn, evaluate cotangent. So then I'm going to come off to the side and say cotangent of A is the reciprocal of tangent. Tangent was opposite over adjacent, so cotangent would be adjacent over opposite. Okay, so this would be 4 over, and then with respect to angle A, y would be the opposite side. So 4/3. All right. So again, right triangle applications, get a sketch, and you'll be good to go. Next example is a little bit more complex in that we're using reference angles, right? So we're talking about reference angles. So we have suppose that phi, okay, pronounced P-H-I, spelled P-H-I, pronounced phi, is an angle in standard position such that phi is between pi/2 and pi. So if I think about this as an angle, right, in standard position, okay, here's pi/2, here's pi. So phi is somewhere in here. That would be what phi looks like. Okay. So then it says, oh, and it says phi of, or sine of phi prime. So with respect to the reference angle, again, this here would be phi prime, but it says sine of phi prime is 2/3. Find the value of the 6 trigonometric functions of phi. Okay, so notice we need to find it with respect to phi, not phi prime. Okay, how in the world do we do this? Notice that phi prime is an acute angle. So if you could imagine dropping a line segment from where our trigonometric point is on the unit circle down, right? That would make a right triangle, and phi prime is an acute angle. So just to blow this up a little bit, I could have a triangle like this. This would be phi prime, and this would be right angle. Okay, and it says that sine of phi prime is 2/3. This is the opposite over hypotenuse. Okay, now, yes, I know I'm going to write this, and then you're going to yell at me a little bit, and it's okay to yell at me. 2 goes the opposite side, and then 3 is the hypotenuse. And you should yell at me because we're on the unit circle, right? The hypotenuse should be 1. Well, okay, fine, put a 1 there, and then this would be a 2/3. So you could actually envision this 2/3 as like 2/3 over 1 if you want to be strict about it. Okay, you end up with the same ratios regardless of if you have 2/3 for the opposite and 1 for the hypotenuse, or if you have 2 for the opposite and 3 for the hypotenuse. You get the same thing. Okay, I'm going to leave it like this just because this is how we have been working with right triangles. So then I have to find this other side, and I'll let you show it on your own, but it's going to be square root of 5. Okay, so then I have to find, sine of phi, cosine of phi, tangent of phi, cotangent of phi, secant of phi, and cosecant of phi. Okay, so I'm just going to evaluate this in my right triangle. Okay, sine would be 2 over 3. Cosine would be adjacent over hypotenuse square root of 5 over 3. Tangent would be opposite 2 over adjacent 5. Okay, cotangent would be its reciprocal, square root of 5 over 2. Secant, okay, that would be the reciprocal of cosine, 3 over square root 5. And then cosecant would be the reciprocal of sine, so 3/2. Yes and no. These aren't right. Not all of them are right, at least. Okay. Remember that phi is an angle in quadrant 2. Okay. In quadrant 2, sine is positive. Remember ASTC. So then sine and its reciprocal should be positive. And then since we're looking at phi and not phi prime, again, phi prime was just this little reference angle, we would need to make all the trig functions that are not sine and cosecant negative. Okay. So the point of all this is you can use your reference angle to set up your triangle, but then if you're looking at the non-reference angle, make sure you're incorporating the sine based on the quadrant. Okay. Last one. Tangent of z is equal to 1/2 and p of z lies into the third quadrant. Okay, so let's get a little sketch here. So we are on the unit circle because p of z, it says, is a point on the unit circle. Okay, in the third quadrant. Find the value of the other trigonometric functions of z. So again, I have something like this. This would be my angle theta, and z again would be the arc length along the unit circle counterclockwise, so that's z. And then how do we go from here? We know tangent of z is 1/2. Okay, this could be saying like the y over the x. We could look at it like that. The only problem with that is that x is 2, right? So, well, -2 in this case because I'm in the third quadrant, but -2 would be like out here, right? Because this goes out to -1. So how in the world do we work with this? This is where working strictly with the unit circle could bring us into a little bit of difficulty. So what I like to do in this case is think of a triangle instead, and maybe I'll just draw, imagine we had a triangle that was maybe oriented like this in the third quadrant. So we have a right angle here. Here's our an acute angle. We'll call it z in this case. Okay, and then tangent of z. Tangent of z is equal to 1/2, right? Opposite over adjacent. Okay, I promise I'll connect this back to the unit circle. If we go ahead and find the hypotenuse, this would be square root of 5. Lots of square roots of 5 today. And then with that, I can say, okay, I know tangent is already that, so I need still sine of z, cosine of z, tangent of z we already know, then I need cotangent of z, secant of z, and cosecant of z, okay? So I can go ahead and evaluate sine, cosine, all of them using this triangle. Here we go. And there are your answers. Okay. So that's fine, but this wouldn't work on the unit circle. We need a radius of 1. Well, here's what you technically do. You could take this triangle and just scale it down, right? Work with a smaller similar triangle where we do have a radius of 1. That would mean that if we took the hypotenuse that we have of square root of 5 right now, that we would need to make it square root of 5 times smaller, which would make this 2 over square root of 5 and 1 over square root of 5. Okay, and all of our definitions still hold, right? In this smaller triangle, sine of z is now just opposite 1 over square root of 5 over 1, right? And so everything ends up being the same, okay? There is still a mistake that I have made, and that is I haven't taken the quadrant into account, right? So P of z is a point in the third quadrant where tangent and its reciprocal are positive. So the others need to be negative, okay? So if you run into trouble with trying to write this on a unit circle, translate to a triangle, work in the triangle, and it will work out again just by similar triangles.